Average rate of change and instantaneous rate of change. Average rate of change, this is algebra. Instantaneous rate of change is calculus. In calculus, is the study of function changes. How does a function change? We'll discuss two different types of changes. Average rate of change, which just says algebra, and I normally call it AROC, and it goes back to another book we used to use for this class. That's what they called it. And it's better than writing out the words average rate of change. It's AROC, average rate of change. And what in the heck is the average rate of change? The average rate of change of one quantity over another one is the quotient of the change of the first quantity to the change of the other. That's a mathematical definition, and we know what this dang thing is. Average rate of change is the change of one mathematical quantity divided by the change in the other. Change in y divided by change in x. Change in y divided by change in x is something we know as what?
Slope.
The slope of the line. So what's AROC? ARC is what we've known all along for a very long time as M, or the slope. Give me 2 points, I can find the slope. Give me 2 points, I can find the slope of the line between those 2 points. Give me 2 points, I can find the slope of the line between those 2 points. That's what you've been doing. In fact, that's what we did this morning in college algebra. And it says, yes, it looks like the slope of the line between the points A, f of A, and B, f of B. And if you wanted to, you could call this guy x1, y1, x2, y2, and that's what you're used to seeing. I'm going to call it, by the way, since we are in calculus, if I'm finding the slope of the secant, I'm going to usually mark it M sub SEC, slope of the secant line. So average rate of change, given a quantity, you pick 2 points, you draw a line between the 2 points, you find the slope of that line, and then you would be able to find and what does that slope mean? Well, if I'm looking at this particular instance here, if I look at delta y, and that's what the notation I'm going to use for change, over delta x, is that years, and y looks like 1,000 of cases, and the reason why we look at this as being a rate of change is I could write whatever the number is, and the units would be, we'll just make it simple, cases per year. So many cases per year. That's how something is changing. It's a rate, like miles per hour is a speed. So this would be whatever the slope is, cases per year. That says, as time goes on, the number of cases either increase or decrease. In this particular instance, what do I see is happening? What is that slope, positive or negative? Negative. So that says as time goes on, the number of cases decrease. By so much. And the quantity is the value of the slope. So many years go down so many cases. So many years goes down so many cases. Now, the reason why it's called the average rate of change is because in calculus, what you have is a curved object. And what that means is this: I pick two different points and I draw a line. What do you notice I have? A different slope. So what that says is what the secant line does, or what the slope that we know and love so well does, it says there's going to be maybe some changes in, but on the average overall, to get to this point, you're going to go over so many and down so many, on average. Pick two different points, the average is going to be different. And the same thing is true if you think about how traditional slope works. If you're coming down from the mountains, there is usually a triangle. And on this triangle, there's normally a truck. That looks more like Howard. Well, I'm trying to get a smokestack. Diesel. Right? And it might say 6% grade next 10 miles. That's an average rate of change. Well, why? Because if you're thinking about coming down, sometimes you're going down and then you feel yourself going back up a little bit. Then you'll go back down again, right? And you may feel yourself going back up again. But it says by the time you get from the top of the hill really down to the bottom, it's an average drop of 6%. So it kind of levels things out. Now, truckers understand what that means, because the steepness will make a difference into how whether or not they're going to necessarily need to pull off with how heavy a load they have and all the rest of it, and remaining in control of the truck. But that just says, there's going to be some ups and downs, but by the time you get from the top to the bottom, it's an average 6% grade. It's not straight 6% down. Average rate of change. Average rate of change. So there are real life cases of average rates of change. Cool, huh? Oh, maybe.